Earlier on, we talked a little bit about the Nernst equation and said that if we were not under conditions that were standard conditions, that the delta G for a reaction would equal the delta G0 plus RT, L, and Q. Right? So non-standard conditions, standard conditions, and then using the equilibrium constant, not necessarily at equilibrium, for Q. We can do the same thing because remember that delta G is related to E0. We can do the same thing for E0. We find out that the potential of a reaction is equal to the standard potential plus RT over NF Ln Q, right? R in this case has a value of 8.314 joules per Kelvin mole. It's supposed to be a Kelvin per Kelvin mole, as opposed to the 0.08206 liter atmospheres per mole Kelvin. So I just needed joules for units instead of liter atmospheres for units. We also saw back when we were doing the copper penny experiment that if we were to take a look at the reaction of copper 2 plus 2 electrons going to copper metal, that the potential for that, standard potential, was equal to a positive 0.34 volts. And then likewise we also saw that zinc went to zinc 2 plus in solution and 2 electrons, and that was a positive 0.76 volts. So when I add those two reactions together, I could take that blue copper solution, throw some solid zinc into it, and what I would get from that is some copper metal sitting at the bottom and a colorless solution of zinc 2 plus. And the potential for that would be a positive 1.10 volts, right? Now, we did this in one beaker, so we didn't separate those two into half reactions and have two separate half cells. But we can see that this is a spontaneous reaction because E0 is positive. But the question is, was it really 1.10 volts? So I want to take a look at the conditions where we were working with a new penny. And given the concentration of new penny, or the copper 2 plus, it would have been roughly about 0.020 molar. And if I had used about a gram of zinc or so, and all of that zinc had gone into solution, maybe because there was too much acid or something like that in there, the zinc concentration would have been about 0.31 molar. So the question now that I have is, what is the potential of this reaction, given that I'm not under standard conditions? So the potential E is equal to the E0, and just on the last page we said that E0 was 1.10 volts, and then I have to subtract from that 8.314, and that's in units of joules per mole Kelvin. This mole here is a unique mole in that, what's it a mole of? It's a mole of copper 2 plus, it's a mole of zinc 2 plus, it's a mole of copper, it's a mole of zinc. It's a mole of the reaction, if you will. And so the 1.10 volts is also for a mole. So that's R. T, we did this at roughly 280 Kelvin, right? And then I have to divide this by 1, and N is the number of moles of electrons, and so N was 2 moles of electrons, and then I have to divide it by F. particular reaction, we had, let me write it here, we had copper 2 plus zinc going to zinc 2 plus copper metal. And so the product of zinc 2 plus and copper metal doesn't have a concentration, right? We leave solids out, we leave liquids out, but we can incorporate gases and aqueous substances. So the zinc 2 plus is 0.31 divided by the copper 2 plus, which is 0.020, and we raise those to the first power because that's what is the coefficient in the balanced chemical equation. Alright, so if I do my calculation for this, what I end up with is E is equal to 1.10, and I'm going to leave units off here, minus 8.314 times the 298 divided by 2 divided by 96,485 is 0.0128. And then the ln of that number, the ln of 0.31 divided by 0.020 is 15.5. And so that is equal to 1.10 minus 0.0128. And the natural log of 15.5 is 2.74. 2.74 times 0.0128 is minus 0.04. And so what I get for E is 1.06, and that's volts per mole of reaction, if you will. Right? Now the question is, does this make sense? I have 1.06 volts when I'm not under standard conditions, as opposed to 1.10 volts when I'm under standard conditions. So I became less spontaneous because I'm not under standard conditions. Does that make sense? I have a lot more zinc in there, zinc 2 plus, than I have copper 2 plus. And if that's the case, then as I have too much product and not enough reactant, my reaction should shift to the left here and become less spontaneous. My reaction still is spontaneous, but it's less spontaneous than if they were both 1 molar. Right? So it does make sense. What would happen if I were to add more zinc 2 plus to this solution? Right? So if I were to dissolve a bunch more zinc 2 plus and bring that in, my voltage would get even less, right? Because I would have more product in there, and that is going to give me a bigger number to subtract from that 1.10. So more zinc 2 plus is going to be problematic. And what happens as this reaction moves forward, right? As this reaction moves forward, I start precipitating out that copper. I get less and less copper 2 plus, and I get more and more zinc 2 plus. So as I decrease the copper 2 plus, again, my reaction becomes less and less spontaneous. Eventually, the reaction becomes so much less spontaneous that the voltage will drop to 0 volts. And if the voltage drops to 0 volts, then it is not spontaneous anymore, and therefore the reaction will stop. So, when taking a look at reasons why the reaction only gave me a 77% yield, certainly one of the responses could be that the voltage eventually became non-spontaneous, and so there could even be some copper, there will be some copper 2 plus ions still in solution, and they will not precipitate out as copper metal. So again, Le Chatelier's principle backs this up, and so that's the end of that story.